Query processor. The query processor components include there are two or more components for query processor. First component is DDL interpreter, which interprets DDL statements and records the definitions in the data dictionary. The DDL interpreter can record the definitions in the data dictionary, record the definition in the data dictionary. DML compiler. What do you mean by DML compiler? Which translate the DML statements, translates the DML statements in query language into an evaluation plan, consisting of low-level instruction that the query evaluation engine understand. In DML, what can do DML? DML translates the query language into an evaluation plan consisting of low-level instructions that the query evaluation engine understands. A query can usually be translated into any number of alternative evaluation plans that all give the same result. DML compiler also performs query optimization. That is, it picks the lowest cost evaluation plan from among the alternatives. It picks the lowest cost evaluation plan from the among the alternatives. Next, query evaluation engine. What can do query evaluation engine? Which executes low-level instructions generated by the DML compiler. Next is storage manager. What is storage manager? Storage manager is a program module that provides the interface between the low-level data stored in the database and the application programs. Query submitted to the system. The storage manager is responsible for the interaction with the file manager. Query manager, the storage manager is responsible for the interaction with the file manager. Next, the storage manager components include what are the components of storage manager? The first component is authorization and integrity manager, and second component is the transaction manager. Third component is file manager. Fourth component is buffer manager. First component is authorization and integrity manager. Second component is transaction manager. Third component is file manager. Fourth component is buffer manager. Storage manager component. First, authorization and integrity manager, which test for the satisfaction of integrity constraints and checks the authority of users to access data. Transaction manager, which ensures that the database remains in consistent, that is in correct state, despite system failures. And the concurrent transaction execution proceed without conflicting. And file manager, which manages the allocation of space on disk storage and the data structures used to represent information stored on disk. Buffer manager, which is responsible for fetching data from disk storage into main memory and deciding what data to cache in main memory. The buffer manager is a crucial part of the database, important part of the database system, since it enables the database to handle data sizes that are much larger than the size of memory. This is a buffer manager. Next part is a transaction manager. Transaction is a collection of operations that performs a single logical function in a database application. Each transaction is a unit of both atomicity and consistency. Thus, we require that transaction do not violate any database consistency constraints. Next, conceptual database design, uh, entity relationship modeling, entity relationship modeling. Database design techniques. First is database design techniques, ER modeling, and second is normalization. ER modeling is a top-down approach, and normalization is a bottom-up approach. What is ER modeling? What is ER modeling? A graphical technique for understanding and organizing the data independent of the actual database implementation. We need to be familiar with the following terms to go further. Then, what do you mean by entity? And this concept is based to ER modeling. What do you mean by entity? Anything that has an independent existence. Anything that has an independent existence about which we collect data. It is known as entity type. In ER modeling, notation for entity is given below. This is a entity existence. Entity instance is a particular member of the entity type. Example for entity instance, particular employee is a entity, regular entity, weak entity. An entity which has its own key attribute is a regular entity. Example for employee. And weak entity, the entity which depends on other entity for its existence and does not have any key attribute of its own is called weak entity. Next, example for a weak entity. In a parent or child relationship, parent is considered as a strong entity and the child is a weak entity. In ER modeling, notation for weak entity is given bold, is given below. This is a weak entity symbol and above is a strong entity symbol. Attributes. What are attributes? Properties of characters which describes entities are called attributes. The properties or characteristics which describe entities are called attributes. In ER modeling, notation for attribute is given below. This is a notation for attribute. It's the domain of attributes. The set of possible values that an attribute can take is called domain of the attribute. For example, the attribute day make any value from the set of Monday. These are domain of attributes. Hence, this set can be termed as domain of attribute day. Key attribute. The attribute or combination attribute which is a unique for every entity instance is called key attribute. Example, the employee ID of an employee, PAN card number of a person, etc. If the key attribute consists of two or more attributes in combination, is called a composite key. In ER modeling, notation of key attribute is given below. This is a symbol for key attribute. Next, simple attribute. If an attribute cannot be divided into simpler component, it is a simple attribute. Example for simple attribute, employee underscore ID of an employee. This is a simple attribute. And composite attribute. If an attribute can be split into components, it is called a composite attribute. Example for composite attribute, name of the employee, which can be split into first underscore name, middle underscore name, and last underscore name. This is a composite attribute. Next, single valued attributes. If an attribute can take only a single value for each entity instance, it is a single value attribute. Example for single value attribute, age of a student. It can take only one value for a particular student, hence it is a single value attribute. Next, multi-valued attributes. If an attribute can take more than one value for each entity instance, it is a multi-value attribute. Telephone number of an employee. A particular employee may have multiple telephone numbers. This is a multi-value attribute, telephone number of an employee. A particular employee may have multiple telephone numbers. If an attribute can take more than one value for each entity instance, it is a multi-value attribute. Example for multi-value attribute, telephone number of an employee. A particular employee may have multiple telephone numbers. In ER modeling, notation for multi-value attribute is given below. This is a multi-value attributes. Stored attributes. Attributes which needs to be stored permanently is a stored attribute. Example for stored attribute is name of a student. Derived attribute, an attribute which can be calculated or derived based on other attributes is a derived attribute. Example for derived attribute, age of employee, which can be calculated from date of birth and current date. Hence, it is a derived attribute. In ER modeling, notation for derived attribute is this is a notation for derived attribute. Relationships. Associations between entities are called relationships. Example, an employee works for an organization. Here, works for a relation between the entities employee and organization. Employee and organization, there is a relation. In ER modeling, notation for relationship is given by this is a notation for relationships. However, in ER modeling, to connect a weak entity with others, you should use a weak relationship notation. This is a weak relationship notation. Next, degree of relationship. Degree of relationship is the number of entity types involved. The n-array relationship is the general form of degree n. General form of degree n. Special cases are unary, binary, and ternary, whether the degrees is 1, 2, and 3 respectively. Example of unary relationship, uh, an employee is a manager of another employee. Example of binary relation, an employee works for department. Example for ternary relationship, customer purchase item from shopkeeper. Cardinality of a relationship. Relationship cardinality specifies how many of each entity type is allowed. Relation can have four possible connected as given below. One-to-one relationship, one-to-many relationship, many-to-one relationship, many-to-many relationships. The minimum and maximum values of this connectivity is called the cardinality of the relationship. Example for cardinality, one-to-one. Employee is assigned with a parking space. E1 is assigned with P1, E2 is assigned with P3. This is a one-to-one employee and parking scheme. This is a one-to-one relationship. One employee is assigned with only one parking space and one parking space is assigned to only one employee. Hence, it is a one-to-one relationship and cardinality is one-to-one. In ER modeling, this can be mentioned using notations as given below. Employee is assigned with parking space, that is one-to-one relationship. Example for cardinality, one-to-many. Organization has employees. O1 is related with E1 and E3, and O2 is related with E2 and E5, E4, and O3 is related E6, organization and employee relationships. One organization can have many employees, but one employee works in only one organization. Hence, it is a one-to-one relationship. But one-to-one relationship, one-to-n relationship. This is a one to n relationship. This type of relationship is called one to n relationship. In ER modeling, this can be mentioned using notations as given below. Organizations, uh, organizations, one organization one has a relationship with employee. Example for cardinality, many to one. It is the reverse of the one to many relationship. Employee works in organization. Employee works in organization. This is a employee E1, E2, E3, E4, E5, and this is related with organization. This is a many to one. One employee works in only one organization. One employee works in only one organization, but one organization can have many employees. One organization can have many employees. One organization can have many employees. This is a M to one relationship. This is a next in ER modeling. This can be uh, in ER modeling. This can be mentioned using notation as given below. Employee EM and works in only one organization. Cardinality, many to many. A student enrolls for courses. One student can enroll for many students. Student can enroll for many students and one course can be enrolled by many students. Hence, it is a M2N relationship and cardinality is many to many. In ER modeling, this can be mentioned using notations as given below. Student enroll with course, relationship participation, total. In total participation, every entity instance will be connected to the relationship to another instance of other participating entity types. And next, partial example of relationship participation. Consider the relationship. Employee is the head of the department. Here, all employees will not be the head of the department. Only one employee will be the head of the department. In other words, only few instances of employee entity participate in the above relationship. So employee entities participation is a partial in the said relationships. Thank you.